So whenever we do the word problems, the biggest thing here is making sure you pay attention to, is it an or statement? Is it a compound inequality? Is it going to be an absolute value, or is it just a regular inequality? Okay, to where there's not two parts to it. So it's really not any different. So it says in Missouri, temperatures can range from 118 degrees down to negative 40. Okay, that's the highest temperature in Missouri versus the lowest temperature in Missouri. Write the temperature range for Missouri as a compound inequality in degrees Fahrenheit and then in degrees Celsius. We're just going to worry about in degrees Fahrenheit for right now. So it's a compound inequality. How are we going to write this? Is it going to be an and or an or statement? Why? Why is it an and statement? You're right. I just want to know why. Okay. So since those two values are included, then because it's actually been negative 40 and 118, we have to include those two values. It says your brother has $2,000 saved for vacation. His airplane ticket is $637. Write and solve an inequality to find out how much he can spend for everything else. So, pretty straightforward. Is this a compound, or is this just a regular inequality? Just a regular inequality. Okay? So this is like what we're going to go back to from 1.6. So how are we going to write this? What are my values? $2,000. Now we're not going to solve it. Let's write it first. So if we have $2,000... everything else is going to go over here, right? He has $2,000. What symbol am I going to use? Am I going to use a less than? Am I going to use a greater than? Less than or equal to? So you want to go here. Why greater than? Why do you want to change it? Right. Can't spend more than what you have. Okay. So we're just taking straight cash. We're not taking credit cards or anything else. Okay? So 2,000 is the biggest number. We can spend less than that, but we can't spend more than that. Okay? If we had it going where it was 2,000 less than or equal to, then that would have said, hey, you can spend more than the $2,000. Hey, we don't want to do that. We're not putting ourselves in debt over a vacation. So then how are we going to write the actual equation part of the inequality? X plus 637, right? Why is it not minus? Right, you're going to have to subtract it from the other side, right? So he has $2,000. Then we're going to have to go ahead and subtract the 637. So we can actually solve it. So there's my inequality here. Whenever we actually do the math, if we go minus 637, we have $1,363. Now, you can rewrite it and put X on the left side, but if you do that, so if you actually solve it and we flip it around, make sure you flip the sign as well. The symbol, not the sign. Right, because we took everything. Since we put the X over on the left side. Oh, I flipped it the first time, didn't I? My fault. So that should be there, and then my bad. There we go. That better? That's better. Whenever we talk about a tolerance example, it's going to be an absolute value inequality where your general format is going to be X minus the average divided by the variability. So like if it says that it can be between, you're looking for the middle number between your window, is how I word it. So if it says physicians consider an adult's normal body temperature to be within 1 degree Fahrenheit of 98.6. So you go to the doctor, first thing they do, they check your temperature, and they say, yes, you have a fever, no, you do not. Okay? So 98.6 is normal. So if we kind of think about this, it says write an absolute value inequality that describes a range of normal body temperature from there. So what is my range? We're going to kind of think of this and work it kind of backwards. So if 98.6 is normal, what's the range that my body temperature can actually be to be considered normal? Right. So what did you do? So you said 97.6 to 99.6. What did you do with those two values? What did you do with yeah, you added 1 and subtracted 1. Okay? So if your variability is x minus the average, well, what is the average? What's normal? 98.6. So I'm going to have the absolute value of, we'll just go x minus 98.6, because that's the middle, or that's the middle of it, less than or equal to 1. The variability is 1, right? 1 above, 1 below. Biggest thing here is trying to use a little bit of common sense and say, okay, what's my window? Where can everything fit in? Okay? Whereas, because if I actually set this up and would actually have to solve this, I would have x minus 98.6 less than 1, less than or equal to 1, less than or equal to negative 1. Well, what's really that doing? If we add 98.6 to each side, didn't we just add 1 and subtract 1? That's what you told me you did anyway. It's just a fancy way of writing it. Okay, a fancy way of telling me how your math worked. Now, here, and we're not going to have probably time to finish it, but we can at least talk about it. It says 95%. It talks about 4,000 Air Force men were measured, okay, people in the Air Force. So then they know how big to make panels on like planes, helicopters, things like that. So it says 95% of the palm width P were within 0.26 inches of 3.49. So what's my average? So if I have x minus the average, what is the average? What's going to go into the part in red? The 3.49, because that's normal. Was within this range. So what's my variability then? The 0.26, right? So knowing what it means to be the average and the variable, like what is it above and below, is key here. Okay, as far as setting it up. Then you would solve it, then you would graph it, and then obviously then write the interval notation as well. Your assignments on Canvas, it's basically just kind of it's 1.6, 1.7 review. Some of it's stuff we did on Friday, some of it's stuff we finished up today, and then obviously the word problems.